this part. We okay, we need to import my NumPy, of course. And I think we were talking about okay, so A is this array. So basically A is a list 2, 3, 5, 16, 25, 4, 5, 4, 41, 57, a bunch of numbers that are having ups and downs. And then B is what? B is like just constructing a Boolean NumPy array. Okay, so basically for whatever elements that are less than 15 is going to return a true for that entry. And then for everything that's above, it's going to be a false. So it's going to be true, true, true. Okay, so those are less than 15. These ones are larger, so it's going to be falses. And then we have truths, and then we have false, two truths and two falses. Okay, so that's like that. And then now we can also sort of like doing a slicing. Okay, so this is basically saying for the indices a less than 15. Okay, I'm gonna extract the array a. Okay, so that's doable and efficiently. Okay, so this is sort of like picking up the elements that satisfy certain conditions. So earlier when we do a list, okay, or at least comprehension is like an if statement, right? But here it's directly in the index part. Okay, so that's a little bit special. So now, what's the difference between Python list and NumPy array? So let's quickly go back to the notes and we highlight. So yeah, that's you can say that's the conditional. So conditional. Hmm. So conditional, and also these are the indices. Okay, index. So NumPy arrays, okay, they support vectorized operations. Meaning what? Meaning basically the data structure is going to be more condensed and more efficiently computed. So that's what they call vectorized operations. So instead of doing loops, so basically it's sort of like, okay, you want to perform and do something that's getting you the same effect of a loop, but now it's much more efficient. Um, And another thing here is that once the NumPy array is created, you cannot change the size. Okay, so it's a pre-allocation of memory that you have to do beforehand. This is really special about NumPy comparing to Python lists. Remember, Python lists they have larger overhead because for the list you can append anything that you want. But then so that means what? That means for each element, it's possible to be an integer or a float or a string or a boolean or whatever. So all things can be possible. So that means what? That means the overhead of each data type is gonna be allowable, which is gonna be a problem for computational efficiency. All right. So so for arrays, you have one and only one data type. So it will occupy much less space because less overhead. Okay, less overhead in the computational perspective than lists. All right, so now there are other operations, but remember these multiplications, they are going to be done element wise. Okay, so think about this like 3 times a. Okay, so remember what a is. A is the list of numbers, okay, having ups and downs in the integer values. 3 times a is component wise. So every entry you're going to multiply by a 3. Instead, if remember for a list, okay, for a list, if you do 3 times that, it's actually 3 copies of the same list. It's gonna get longer, but it's not the same here. Not the same thing here for NumPy list, NumPy array. So now remember what B is. B is actually a Boolean, right? But now you can also do scalar multiplication. So when 3 times b, you're going to get this. So this is treating truths as ones and falses as zeros. Okay. So here, so this operation, okay, so true becomes one. When you have multiplication, true becomes one and false becomes zero. All right, so that's what's special here. So now you have 3b, which is a list of 333003300, which is a list of the integers. And now you are a multiplying by this array. So that's component-wise multiplication. Okay, so still component-wise. So this is component-wise. So now remember, if you're multiplying two lists component-wise, just like what we discussed about like the distance over time. So if you were doing the list computation, okay, so you can do it by a loop, or you can do the zip of two lists and then as iterated tuples, iterated pairs, right? And then for list comprehension, that can be done, but it's not going to be as efficient as NumPy. Okay, so NumPy here is just component-wise. You get it pass, and then the things are computed. So that's really handy here. But besides the efficiency, there isn't really a lot to emphasize about this code. So yeah, well then yeah, to get to access rows and specific entries, that's the same thing from before. So let's say A2 plus B1. What's A2 plus B1? A2, remember the indices are 0, 1, 2, 3, 4. So A2 is actually this one. Okay. B1 is what? B1 is this one. And basically, we are treating again true as 1. So when you add 5 with true, essentially you're just adding 5 with 1, and then it's going to be a 6. So basically, it's kind of really an elementary in the sense that now true false are just going to be 0 1s. Okay, true false is going to be 1 1 and zeros. Okay, so respectively. All right. So now let's say if you have, so here remember what reshape is. Reshape is basically saying I'm going to put it into 3 by 3 matrix form. Okay. So now the data we have, what we have 2 3 5 in the first row, 16 to 25 5 in the second row, and 4 41 57 in the third row. So that's this. And then when you do A00 plus B12 is what? A00 is the 0 row, 0 column element, which is here. And B12 is the first, the row 1, so 0 1 is the row 1, 0 1 2 is going to be this one. Okay, so it's going to be the true right there. And now that thing is going to be treated as 1 when we do the addition. So it's going to be 2 here plus 1 here, which is a 3. Okay. Really systematic. Question? All right, so yeah, well, similar to before. And now when you talk about slicing, it's the same thing from before. Okay. So here, when we say A range is array, okay, so this is array from range, array range. So basically, A range is really similar to range, but now it's just giving you an array. And we are once again starting from 2, ending at start at 2, stop at 29, step at 3. So basically, these are the integers with increment 3 and stopping at 29, but of course removing 29. So we have, yeah, so the next number here is indeed 29, but it's now removed. But it's an array. And here from 1 through 7, okay, so that's slicing. So just look at the indices 0, 1, and all the way up to 6. Okay, so this 1 through 6. 1, 2, 3, 4, 5, 6. So we're going to look at these numbers here. So indeed, as expected. And then when you have slicing 4 colon nothing, that's what? That's saying I'm starting from 4 all the way to the right. That's right, these. And then I have from 0 to 3, that's slicing colon 4, right? So that's everything up front. That's that. Okay, so indeed as expected. Okay, so slicing is the same thing from before. Right? So nothing really special here. Okay, so this one is a little bit special because it's possible that your data structure is now multidimensional. So there are indices. The first index, the second index, they can all do slicing. So what you see here is that okay, I'm running through all the indices, but I'm doing in the backwards. Okay, so colon -1, you're saying okay, I'm gonna do the reverse order. So now that's what that's basically so I'm just writing it down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my A, right? So that's my A. But now here I'm saying the row index is going to be reversed. So it's this way. But the colon index is colon 1. That's the forward direction. So it's going to be what? It's going to be, that's why we have 7, 7, 8, 9. Okay, so that's the purple arrow indicating the matrix. So 7, 8, 9, 4, 5, 6. So it's still the right to the right, the left to the right, but now it's the bottom to the top. Okay. But and then if we are looking at the colon -1, colon -1, that's saying what? That's saying now both directions are reversed. So it's the bottom row to the top row, the right end column to the left end column. So it's going to be 9, 8, 7. Okay. And then 6, 5, 4, and then 3, 2, 1. All right. So just be reminded about the slicing. Okay, the slicing that we have seen. That in a slightly multi-dimensional situation. So dot copy. Okay, so that's very important. The same thing from the lists. Okay, so if you want to manipulate without affecting the old data, so this is the shallow copy. So a underline copy, okay, underscore copy is basically trying to make a shallow copy of the data so that whatever you do to a underline copy will not affect the matrix A itself. All right. Okay, so now ones and zeros. Okay, so that's also super useful because remember at the beginning of NumPy arrays, you need to specify the dimension. Okay, so it's really natural that you let's say have some matrix like 4 by 3. Then you want to prelocate 4 by 3 data structure, but then possibly you want to fill the matrix up with like ones or fill up the matrix with like zeros instead of varying different numbers. So for instance, let's say you want to construct that identity matrix, right? So you don't really need 1 through 9 or so let's say 3 by 3 identity matrix. So then you don't really need 0 through 9 to prelocate the memory and then change the numbers. You can directly do this the np.1s or np.0s. So now it becomes the 3 by 3 zero matrix and then change some coordinates to make it diagonal. Okay. So they are special attributes. Well, excuse me. There are special methods for constructing for constructing constant matrices. Mm, let's see. This figure actually is interesting to talk about. So what's special here? We have a surface. Okay, we have z equals to x squared minus y squared minus 10. So this is actually what? This is actually a quadratic surface. I think it's called hyperbolic paraboloid. But basically, you have like a horse saddle shape, okay, for the curve. But then what we see special here is that this is a range from -10 to 10 with the 0.25 as the increment of the data. Okay, so that's my you can say the step size, which is not integer. Okay, so that's special here. Non-integer increments. This is what's allowed in NumPy. Okay, that's pretty interesting. Okay, non-integer step size. And then mesh grid is basically forming up a 2 by 2 matrix of all these possible xy values, which is what's called a mesh grid. And let's look at the plot. Let's look at the plot. Uh, run it. Wait. Yeah, let's run all. Yeah, this okay. This is not executable. That's what we know. Let me uncomment this so that it just runs through. What? Okay, there's some syntax that's not supported at the moment. Okay, certain features are modified. Okay, let me see how it's suggested here. That's unexpected. Okay, completely dead. So yeah, well, yeah, okay, this part I will try to figure it out a little bit later. But that's weird. That's pretty weird. Plotting, yeah, okay. So NumPy arrays. So, what else? Okay, random. So there are a few random sequences that you can random data that you can generate out of NumPy. So without really looking at really enhanced statistic packages. So we have random int. So that's random integer. So 10 and size 6, meaning we are having a range from 0 to 10, but then the data size is just 6. Okay, so one-dimensional array. And then if you have 3, 4, it's basically saying we have 3 rows and 4 columns. And then 3, 4, 5 is basically uh, It's just going to be a tensor. Okay, so let's try that. So basically, the numbers are randomized in the sense that okay, so we have three 4 by 5 matrices. Okay, so the leading three is actually the number of layers. Okay, of your matrices. Okay, it's a 3 layer thing. Mm, so the thing here, what about the random package is that every time you execute, it will give you a different output. So every time it's randomized. And suppose you want to get predetermined. So if you want the randomness to be sort of fixed for your stability of your the analyze your code. Okay, so you may want to get a random seed. So let's okay, so random integer, so size 6. So random arrays, so you can do uniform random, that's RND. So that's uniform random between 0 and 1, excluding 1, 2 by 2. So that's specifying the dimension of your data. And then normal distribution is going to be rand n, INDN. So the standard normal, okay, meaning it's going to be mean 0 and variance 1. If you have random ins, you will be able to allow the lower and upper bounds for your randomized integer. And if you just want one random number between 0 and 1, you can just do random.random. So these are the methods, okay, to generate random numbers. So wait, these two cells, are they the same? Oh, right. So another special thing is that, okay, if you want to do random strings or other random outputs instead of numbers, okay, you can do something like this. It's going to be random choice. Choosing A, E, I, O, U, so with a size of 10. But then if you want to generate with unequal probability, let's say if you want to have A, that's 0.3. So basically, this is going to be a list of numbers that add to 1. Okay, so this is assigning the probability here. So 0.4 meaning it's going to have higher probability to return you the string O, and a little bit less, okay, for the string A, and the list for E and I as like 10%. So 10% for E, I, and U. Okay, A and O, they have the larger percentages. So yeah, right. Random seeds. That's really important, especially when you want to have random procedure, but you also want to sort of fix the randomization and analyze the procedure how it runs. So you don't really want it to change every time. So then what you do is at the beginning you just set up the random seed to be something like this. So now the same code from before. I'm trying to randomize a 3 by 4 matrix with integers from 0 to 10, right? But now every time I run it, the seed is the seed 0. So the output is always the same thing. Okay. Now, if I give a random seed that's different, let's say 1000, it will just give you a fixed output at the same time, but it's just going to be different. For every different random seed, you will get a different randomized output. Let's see. So yeah. So for different seed, it will just give you sort of like a different hash, okay, for your randomization. So this can help you analyze your code, especially if you want to do something like a gradient descent or stochastic gradient descent. Yeah, well, the live coding lecture of lecture 10 is actually not really difficult. So I would say play with it, and I will share the live coding notes that's already established. but it's going to be after class. All right, so that's pretty much for today. I would say, yeah, well, the randomization it will be needed for some of your homework questions, but it's not going to be an emphasis for the final. There will be a few questions regarding the arrays. Okay, so let me stop the recording, and of course, if you have